So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 356 and in this video we want to talk about the user-defined conversion function. So and again here in the CPP reference we go to the language section, and again here in classes we talked about the converting constructor. We can click on this one and you can find here the user-defined conversion function by clicking here, or you can go back again and then here down to the section conversion, and then it says here user defined, and you can click here as well. It's the same thing. First of all, what is a user defined conversion function? And let's read here the first line, and it says here enables implicit conversion or explicit conversion from a class type to another type. In our last video we talked a little bit about implicit conversion with constructors and explicit conversion with constructors. The main point was that implicit conversion was all time possible, explicit conversion was not all time possible, especially not with copy constructor. And here it will be the same a little bit, but of course it is just a little part of it. When you click on this one, for example, then you can see there is much more things which we skip for now because we won't talk about the user-defined conversion function here. Let's clarify this part here where it says from a class type to another type. And for this part we go here down to the example. First of all, what is a class type? Here struct X is a class type, or could be called class X, struct X, or union X. This X is our class type, and we want now to convert it to another type, for example int or whatever you want. But let's try to compare this one to the converting constructor which we learned in our last video. So I go here to the converting constructor, and here are the examples, and here let's take this example, and here we see we have here the one which is anything, we don't know whatever. We are trying to assign this one to A1, and with the converting constructor we know we have to check the class as well, and then the constructor who fits this one here will be called. For example, in this case one could be an int. The compiler said okay, I can treat you as an int, then I can call this one, and this converting constructor is called. Okay, now let's compare this one to our user-defined conversion function, and I go here back to the examples. Again, here is our struct X. Here on bottom we have we're creating an X object, also called X, and let's take this here, this example here, and you can see here something strange. The first thing is we take the object and we are assigning to an int. So you can see here we convert the class type X to another object, here int in this case. When I go back to the converting constructor, here it was a little bit different, right? In this case we took from the other side anything, in this case a int, and then we tried to find in the class a usable constructor, and then we created the class type itself. And again I go here back to our user-defined function. In this case we are converting the class type itself away to something new. This is so the main thing what we have to learn, but first we have to talk about the syntax here and watch these examples later a little bit more in detail. Okay, let's talk about the syntax here a little bit. First of all, let's read this one. It says here conversion function is declared like a non-static member function. Again, a non-static member function means just a normal function with the without the word stat, like this one here. There is not the word static and we can use it. Then our member function template, this one we skip because we have not talked about templates, with no parameters, no explicit return type. This is interesting. We talk about functions, but we have no return type. And then you think, okay, no return type means void, but void is also not allowed. This is something new. Okay. And then end with the name of the form. And then we go here step by step. Now we have here operator, and then conversion type ID. And here number one says declares a user-defined conversion function that participates in implicit and explicit conversion. The nice thing is in our last video we talked already about implicit and explicit conversion, but with constructors they are similar. Implicit means you can use copy assignment, and explicit means you can't use copy assignment. So here it is similar, but we have to talk about the word operator and conversion conversion type ID a little bit more in detail. Let's start here with the word operator, and this keyword we already learned, and most time when you see the word operator, many people think first of all of operator overloading, like I would think that too, but there is a problem. This word operator has many more meanings in different contexts, and here in this AI of Google I show you all the operator syntax which are possible. For example, this one we know, this is the operator overloading, which we learned at first. And how does this work? We already learned. We take an operator. This kind of operator is, for example, plus. They are limited operators which you can take, but if you take, you can give them a different meaning, which means you can add to objects. Like here they are adding to objects, and here if I want I could just replace here this one, delete this one, and put in std hello world, and this here would later print hello world or something like that. We learned this kind of stuff with operator overloading. You give this word operator, and the operator is in this case this one of the symbols, a new meaning. Okay, but now we have here other operator context. For example, this is that what we are going to learn today. It is the user-defined conversion function. It behaves a little bit different, but I want to show you also the other ones here, which we are not going to learn here, but just that you keep this in mind, that the word operator has different kinds of meanings in different contexts. Here we have custom memory management, and you can see the operator is here combined here with the word new, and here we have even a return value. Okay, then literal operators. Here you can see again we have here our word operator, and then we have here this kind of stuff. We will talk about this when we are going there. I won't just show you. And here we have not even talked about coroutine, but we have here first talk about coroutines, and then we will talk about the operator with coroutine, and this one looks like that. So in short, you are learning in this video the second use of operator. The first one you already know, operator overloading, and now we are going to user-defined conversion functions with the word operator. And now let's talk about the second part, which says conversion type ID, and I want that you read this here on your own, because I want to explain this part with functions so it's easier to follow along instead of trying to understand these words here. Okay, let's go here to this example down, and we are using the syntax, the first syntax, to explain this step by step. Let's start. First of all, we have the operator. Okay, this is the syntax operator here, and then we are asking what is here the conversion type ID. Very important. The conversion type ID is just the int without this parenthesis, because this belongs to the operator function declaration syntax. Okay, so this is the conversion type ID. And what does this mean? This is the thing which we want as a result. Later we will see an example down here, but this is our goal. All right, and then const means just again to make this function const, and here in the body you can write what you want. In this case they write whatever. When it is converted, we will assign 7 to it. Important here is also you realized, first of all, this is a function, has no return type. That was here stated. No explicit return type, not void, and no return type at all. And the next thing is important, also with no parameters. So we have also here no parameters. So in this case here, there should be no parameters, because our goal is just this here in. And that's it for this one. And we are jumping now down to this example here below. Okay, and here, first of all, we are creating an object X. Okay, that's very easy. We are using the struct X here. Here is no constructors at all, but we learn the compiler is then creating implicitly a constructor, so we can create this object here, and we have everything here available. Okay, now we're jumping to this example, not this one, because here I have to talk a little bit more. So in this case we want to do what? First we want to create a new variable name called m with the type int. We are creating it by assigning X to it. Okay, and when we see something like that, we have now to jump to the type of X. In this case, it's our struct X here on top. And then we have to check if we can convert this struct X to an int. And the first thing what you should check is is there an operator which can convert this? And in our case, we have this word operator here. That's good. It is not an overloading operator. That's also good, because overload operator will not help us here. We have here indeed a conversion operator. This will help us. And now we have just to use that and check if this is possible. Okay, now we just call x with the operator like a function. And how we do this, so we are on the right side, x is calling just the operator. The operator is doing just returning the value 7. The target is int. So on the right side here, we are creating 7. We are creating the type int. So we have a temporary value when we convert this here anyhow with 7. And the 7 we can then easily assign to int, because we have created here an int. This is a little bit simplified internally. The compiler will do is a little bit better, of course. Keep this in mind. And one more thing you can see now, this one is called a implicit conversion in this case, and the reason for that is because we are not using the word explicit here. Implicit means you are allowed to use the assignment operator here, and again explicit would not allow that. We will see an example later. Okay, and before I stop here the video, you should understand that the user conversion function compared to the conversion constructor is different in the way how you create this conversion. Here you can see in the conversion function that we start on the right side, but we are using the struct itself, and check here what we have to do, and we can see, okay, we have take the 7, we have to convert it to int. Okay, I call x operator with int, and then I assign it to the new type. And when we go back to the converting constructor, you can see we do something similar there. We start again with the right side, but instead of checking the type on the right side, for example, this would be, we don't even know what this is, and actually here the compiler will determine this one in this example. But let's say it's a int. We are not going into int here and check if there is a conversion. Instead, in the constructor, we are going to the left side and check if a, here in this case, has a constructor which can take what is on the right side. That's a very important difference. And if you understand this, it's very nice. If not, no worry. In the next video, we will go on with the other examples, and perhaps it makes click. So if you have any questions, like all time, write in the comment section. See you in the next video. Bye and good luck.